Hi students, let's study 9th standard ICSE Math chapter 14 rectilinear figures exercise A. Also, to enroll for my online test series or online lectures, email me or message me on Instagram. Check the description for more information. This exercise is not in the scope of syllabus for 9th ICSE. However, if your school has taught this, then you can solve it. Let's start with sum number 2. The angles of a pentagon are in this ratio. Find each angle of the pentagon. Now, there are 4 main formulae you have to remember for this chapter. So, take this and learn these formulae. A polygon is any figure with many sides. A regular polygon will have all the sides equal. So a regular polygon with 3 sides is called an equilateral triangle. A regular polygon with 4 sides is called as a rhombus. Now the sum of all interior angles of a polygon who has n number of sides is 2n minus 4 into 90 degrees. For example, if it's an equilateral triangle, so that's n is 3, 2 into 3 6, 6 minus 4 2, and 2 into 90 is 180 degrees. That's the sum of all interior angles. And why equilateral triangle? Any triangle's sum is always 180 degrees. This formula is applicable for regular as well as irregular polygons. It doesn't matter whether the sides are equal or not. Similarly, the sum of the exterior angles will always be totally 360 degrees. Sum of all the exterior angles. Now, particularly for regular polygons, we have 2 more formulae. Here we have the total of interior angles and total of exterior angles. But what if we want to find each interior angle or each exterior angle? Then we simply divide the total by n, which is the number of sides, because if there are 5 sides, there will be 5 interior angles. So these are the formulae we will use for the exercise. Using this knowledge, how would you solve this sum? Think about it. Since a ratio is given, the first thing we do is we let the angles be 4x, 8x, 6x, 4x and 5x degrees respectively. Then we say that the sum of angles is this formula. Now remember, there is no mention that it is a regular pentagon. It doesn't matter. This formula is always applicable. Now using this formula, n is how much? 5. Pentagon has 5 sides. So 10 minus 4 into 90 is equal to the addition of all the angles. So we solve this, get the value of x, substitute and get the individual interior angles. Next, the 4th sum. In a polygon, there are 5 right angles. Oh great, so the sum of those 5 angles will be 5 into 90, which is 450. And then the remaining angles. How many angles are remaining? We don't know that because we don't know how many sided polygon it is. But the remaining angles are equal to 195 degrees each. So find the number of sides. The number of sides is n. Out of the n sides, 5 are right angles. So how many angles are left which are not right angles? N minus 5. And each of these is equal to 195. Now the sum of all angles is this formula, but the sum of angles is 450, that is the 5 right angles, plus 195 multiplied by the remaining angles. This is the total sum of interior angles, which is equal to this formula. So we have an equation where there is only one unknown variable, n. So this is just simple algebra. Open the brackets, rearrange the terms, be careful about the signs, and we get the answer as 13. So the number of sides of the polygon is 13. Out of which, how many angles, out of the 13 angles, interior angles, how many angles were right angles? 5. And how many angles were 195 degrees each? 8. That's right. Now the 7th sum is IMP. It's a pentagon where AB is parallel to DC. Pentagon means 5 sides and they are parallel, and the remaining 3 angles are in a ratio, and find the angle E. So this is approximately a diagram. You can draw any kind of pentagon, but make sure that you show AB parallel to CD. That doesn't mean that angle B and C are 90 degrees each, but the sum of angle B and C will definitely be 180 degrees. That's a property of parallel lines. The co-interior angles, also called the allied angles forming a C between the two parallel lines, are always supplementary. And the remaining 3 angles, since their ratio is given, we'll assume them to be 3x, 4x and 5x respectively. Make sure you write all the reasons. Now sum of angles is always this formula, even though it's not a regular pentagon. But sum of angles according to us will be B plus C is 180, A is 3x, D is 4x and E is 5x. Number of sides is 5. So now we have an equation in terms of x. Solve it and get the value of x. And they've just asked us to find the value of angle E, which is 120 degrees. They've not asked us to find the values of other angles, so don't bother. Next, the 10th sum, which is also IMP. The difference between an exterior angle of n minus 1 sided regular polygon and an exterior angle of n plus 2 sided regular polygon is 6 degrees. Note that the word regular is used here. So the given data suggests that exterior angle of the first polygon minus exterior angle of the second polygon is 6 degrees. Make sure that this is a bigger angle and this is a smaller angle, because only then the difference will be a positive number. How do we calculate each exterior angle of a polygon? Well, it's always 360 upon number of sides. And 360 upon number of sides. But how do we know that this is bigger than this? N minus 1 means that it's a smaller denominator. And remember that if the denominator is smaller, the fraction is bigger. So it is this minus this is equal to 6. Now again, it's normal algebra. You remove the LCM, cross multiply, open the brackets, and it becomes a quadratic equation. Then you try to simplify the quadratic equation by dividing the whole equation by 6 as it's possible. Then you do splitting the middle term such that the product gives you 182 minus 182 and their addition gives you plus 1. Then you do grouping, so you get 2 brackets equal to 0. So n is either equal to 14 or n is equal to minus 13, but negative value is not possible. How can number of polygons be negative? At least in our world, it's not possible. Maybe in some another parallel universe, this might be possible. So the number of sides is 14, and that's the end of the sum. And finally, the 11th sum. 2 alternate sides of a regular polygon meet at a right angle. We don't know the number of sides of a polygon, so we can't even complete this figure. It's a regular polygon, means all sides are equal. And we know that alternate sides, that is EA and CB, they are not adjacent sides, they are alternate sides because there is one more side in between. When they are extended, they meet at a right angle, that is mentioned in the question. So the given is not given, so write the given here like this. Now in this triangle ADB, this angle is equal to this angle. Because it's a regular polygon, that means each exterior angle is equal. This is called an interior angle. Even they are equal, of course. And this is called exterior angle, which is a linear pair with the interior angle. This actually, the diagram is not perfect. This should have been a straight line like this. You draw it properly. So the exterior angles are also equal because it's a regular polygon. So let's assume it to be x and x. And this is 90. So by angle sum property, we can find the value of x, which comes up to be 45 degrees. So we found the value of each exterior angle, but we already have a formula for that, 360 upon n. So we get the value of n, which is the number of sides.